We're diving into a fascinating and perhaps controversial topic today, the possibility of time travel. Many physicists have explored the theoretical framework, but is it truly scientific or something else entirely?
The question of time travel often gets entangled with our understanding of general relativity and quantum mechanics. While general relativity allows for the theoretical possibility of closed timelike curves, the implications are far more complex than initially perceived.
Exactly. The paper we're discussing challenges the very foundation of the time travel narrative. It argues that a key, unstated assumption underlying the possibility of time travel is fundamentally flawed.
That's right. The assumption that zero change to the past implies zero change to the present is logically inconsistent. This renders the whole concept of time travel into the past, as it's currently understood, unscientific.
So this isn't just saying time travel is unlikely, it's suggesting the very idea is built on a logical contradiction. Let's unpack that. The paper uses the term pseudoscience. Can you clarify what constitutes pseudoscience in this context?
Pseudoscience isn't simply a false statement. It's a claim presented as scientific, but lacking the fundamental characteristics of scientific inquiry. A logically contradictory statement, for example, cannot be tested or falsified through experimentation. It's inherently false by logical necessity. Time travel, as often presented, falls into this category.
So a theory built on a logical contradiction isn't just wrong, it's not even a proper scientific theory.
Precisely. It's outside the realm of scientific investigation. The paper argues that the current discourse around time travel suffers from this fundamental flaw.
What's this crucial unstated assumption the paper identifies?
The assumption is that if you make zero changes to the past, you'll make zero changes to the present. This seems intuitive, but it's demonstrably false.
But isn't that the whole point of careful time travel? To avoid paradoxes by minimizing interference?
That's the common belief, yes. But even passive observation requires interaction. Your presence in the past, however subtle, inevitably alters the timeline. The paper uses a quantum interference experiment to illustrate this.
Can you explain the quantum interference experiment example?
Imagine a time traveler observing a quantum experiment in the past. Even if they don't physically interact, the act of observation changes the probability of the outcome. The very act of their presence, even without direct interaction, alters the past and thus the future.
So the time traveler's intention to make no changes is irrelevant?
Absolutely. The paper shows that the probability of a time traveler making zero changes to the present, given the vast number of quantum events between their arrival in the past and their return to the present, is effectively zero.
This ties into the butterfly effect, doesn't it? The idea that tiny changes can have massive consequences.
Precisely. The paper highlights the sensitivity of nonlinear systems to initial conditions. Even minuscule changes in the past, caused by the time traveler's presence, could lead to significant alterations in the present.
So the idea of a time traveler carefully navigating the past to avoid paradoxes is a fantasy?
According to this paper's argument, yes. The very act of time travel guarantees a change to the present, regardless of the traveler's intentions.
The paper addresses a potential objection, the idea of a deterministic block universe where the past, present, and future are fixed. How does it counter this?
Even in a deterministic block universe, the time traveler's perspective is crucial. The paper argues that the time traveler cannot avoid changing their perceived present universe. The very act of time travel, from their perspective, necessitates a change.
Right, so even if the universe is predetermined, the time traveler's experience is still altered?
Yes. The paper's logic holds even if we assume determinism. The time traveler's presence in the past, regardless of their intentions, alters their future.
How does the many-world interpretation, MWI, of quantum mechanics factor into this discussion?
The MWI doesn't invalidate the paper's argument. Even if we accept MWI, the time traveler's experience is still altered. They might find themselves in a different branch of the multiverse, but that doesn't negate the fact that their present has changed.
I see. So the MWI doesn't offer a loophole to the paper's central argument?
No. The core issue is the logical inconsistency inherent in the assumption that zero past change equals zero present change. This holds regardless of the interpretation of quantum mechanics.
So to summarize, the paper argues that the very concept of time travel into the past, as it's commonly understood, is based on a logical fallacy.
Exactly. The assumption that zero change to the past implies zero change to the present is false. This renders the possibility of time travel into the past not just improbable, but logically impossible and therefore pseudoscientific.
A compelling argument indeed. It challenges us to rethink the very foundations of this popular, yet perhaps ultimately unscientific idea. That was a great discussion.